It says solve each of the following equations from 0 to 360.
Oh, so we were gonna finish the chapter and then follow the other plan?
Yeah, this was left. We just like we need to cover all the aspects. We can
Okay.
skip, but we'll touch all the subtopics.
Okay.
So 9.6, solve each of them. Sin x is equals to 0.3. Solving from 0 to 360, making sure calculator is in degree mode. Basic angle is sine inverse of 0.3. I'm getting 17.5. When we have this basic angle, we know it was positive, and from 0 to 360, sine is positive in first two. So my angle is 17.5 degrees, and 180 minus 17.5, second one comes out to be 162.5. If you look at E part, which is tan x is equals to negative 1.4, basic angle we calculate that using positive numbers only. So shifted tan inverse of 1.4 is 54.5, and tan is negative. Add sugar to coffee. These two areas, tan is negative. So from 0 to 360, the first angle, basic angle is 54.5. 180 minus 54.5 is 125.5, and 360 minus 54.5 is 305.5. In similar way, question 2, and in similar way, question 3, the only difference is the domain. For question 2, domain is in radians. Question 3, domain is till 180 degrees. Let's try some from question number 4. It says solve each of the following equations giving an answer equations for the domain. Okay. So if it says cos of x minus 30 is equal to negative 0.5, and the domain is given that 0 is less than equal to x is less than equal to 360. So this is x minus 30. I'm recreating the domain for x minus 30. So minus 30 in all of these is minus 30 less than equal to x minus 30 is less than equal to 330. And I will just replace this, let's say, with y. So I'll write cos of y is equals to negative 0.5. So basic angle is cos inverse of 0.5. I'm getting 60. Now I have to see that basic angle is 60 and it is equal to negative 0.5. Add sugar to coffee, it is negative in these two quadrants, and basic angle is 60. So my first angle y is equal to 120, and the second angle is equal to 180 plus 60 is 240. And ultimately y was equals to x minus 30 is 120 and 240. So for x, it goes on other side and gets added, becomes 150, and 240 plus 30 is 270. So this was question 4A, 9.6. Question 4A is 150 and 270. Okay, try B part, 4B. Is it working?
Yeah, I'm doing it. So I got 95.72 and 185.72, but we discard that one because that's not in the range and it's just 95.72.
4B. Two answers. 95.7 and 129.3.
What was the second answer?
Yeah, there's a second answer. That is 129.3.
Hmm.
Okay. See, first it was given for x, and we have 2x in the domain. 2x plus 45. So 6 sine 2x plus 45 degrees. If I say this is y, 6 sine y, and the domain, this was equal to minus 5, and the domain is from 0 to 180. 0 to 180, but that was for x. So we change it for 2x first. This is 0, 2x, and 360. Then there's 45 added in all of these. 2x plus 45 and 360 plus 45 is 405. I'm solving for y. So sine y is equals to minus 5 by 6. Basic angle is equals to sine inverse of 5 by 6. I'm getting 55.4. Now when we're working for y, we know that this was negative. So sine is negative in these two. So my first angle needs to be 180 plus 55.4. 180 plus 55.4 is giving me 235.4. And the second angle is 360 minus 55.4. I'm getting 304.6 degrees. Now, definitely we know that 405 is somewhere here. So I'm not checking that. That is already positive and we needed only negative answers. Now for x, x was 2x plus 45 is equals to y. So x is equals to y minus 45 by 2. So 235.4 minus 45 divided by 2 is 95.2. Why am I getting different? Let's carry on. Let's see. 304.6 minus 45 divided by 2 is 129.8. 125, 95.2. That was supposed to be 7. Quickly checking it. 235.4 minus 45 divided by 2. Getting first one as 95. You were getting 97.
Yeah, I was getting
95.7.
97. I'll
I'm
pull up
getting
my
the second.
working. So we first do the 6, 7 to x plus 45 degrees. So that would be negative 5 over 6 and sine inverse. And that's
Oh
just
my God. This was 56.4. I just wrote 55.
Yeah.
All are
Yeah.
50.
Negative 56.44. Yep.
180 plus 56.4 is 236. 236.4 and 360 minus 56.4 is 303.6 minus 45 9.3 and 236.4 minus 45 divided by 2 is 95.7. The two answers. And within the domain 0 to 180 for x. Okay. I'm going for C part. That's long domain 540. This is basically 1.5 circle, one complete and one half. C part says 2 cos of 2x over 3 plus square root 3 is equals to 0 from 0 to 540. 0 is less than equal to x is less than equal to 540. So if I change that into y, 2 cos y plus square root 3 is equals to 0. So I have to multiply it by 2 and divide by 3. 0 stays 0. 2x over 3. So 540 into 2 is 1080 by 3 is 360. So I'm solving for y from 0 to 360. 2 cos y is equals to negative square root 3. Cos y is equal to negative square root 3 by 2. Basic angle is equals to cos inverse of square root 3 by 2. We always calculate with positive. Cos square root 3 by 2 gives me 30 degrees. Basic angle is 30 degrees, solving from 0 to 360, and we knew that it was negative and that's cos. It has to be in these two quadrants. So first one, because of this 30, is 150, and the second one is 180 plus 30, that's 210. Now we calculate x. So 2x over 3 is equals to y. So x is 3 by 2 of y. X is equals to 150 into 3 divided by 2 is 225. And 210 into 3 divided by 2 is 315. Okay. This was C part 4C 225 and 315. Try D part and try to keep it in form of pi. Don't go for decimals or fractions. Keep as fractions or pi or D. We have 3 exercises left in this chapter, including this one.
D part, right?
Yeah, D, doctor.
Okay. So for x, I got pi over 2 and 7 pi over 6.
Pi by 2 and 7 pi by 6. Perfect. Okay, now skipping a few questions. Question number 5 says solve each of these following. Now, one thing is applying identity and making that as one trigonometric ratio and then solving. So solving part is almost done. You know how to do these. So if the question says, let's say 5a, this is 4 sin x is equals to cos x. So I need to change it into one trigonometric ratio. I'm dividing sine with cos. Sin x over cos x is equals to this one on the other side, and this one was being multiplied there and 1 by 4. This is now tan x is equals to 1 by 4. And you know how to handle it from here. So we have to convert it into single ratio. B part says 3 sin x plus 4 cos x is equals to 0. This would be 3 sin x is equals to minus 4 cos x. Again, sine over cos. Sin x over cos x on the other side. Minus 4 is already there. 3 goes there is this. So tan x is equals to negative 4 by 3. We'll solve for this from 0 to 360. Similar way C and D. And same way, sixth part, that is again sine and cos. Okay. 7a part. It says sine x into tan x in x minus 30 degrees. Is equals to 0. Question 7. This shouldn't be. Okay. Because the angles are different, I was trying to convert it into one, but those are different. So I can have the split sin x and this equal to 0. Sin x equals to 0 and tan x minus 30 is equals to 0. I'm solving this incomplete to be sure. So basic angle for sin x is equals to 0 stays 0. Basically, where is sine 0 from 0 to 360 is at 3 places, that is 0, 180 and 360. So first x is 0, 180 and 360. This was 7a. 0, 180 and 360 are part of answers. And then we solve the right hand side, which is tan of x minus 30. So we were solving for 0 to 360. 0 to 360, when you subtract 30, that's minus 30. And y and 330. And this is equal to 0 again. So tan inverse of 0. Basic angle for this is again like tan was 0 at these 3 places, which is 0, 180 and 360. And for x, we take this 30 on the other side and add 30 to everyone. This is 30. 180 plus 30 is 210. This is 390. 390 is going out of domain, so we just leave that. Finally, x should be 0, 30, 180, 210, and 360. Collected all these 5 angles. This was 7a. 0, 30, 180, 210, and 360. Okay. What do you think we'll do in B part? Have any idea how to do B part?
I'm thinking. Well, we could factor out the equation for tan x first of all. So we would solve for x by tan x equals 0 and 5 tan x minus 4 equals 0. So then tan x equals 0, degrees would be x equals 0 degrees, 180 degrees, or 360 degrees. And then,
Right.
so since the given domain is 0 to 360, all of them are valid. And then for 5 tan x minus 4, then it would be tan x, and we would rearrange it, and I believe it would be 4 over 5. Yeah, tan x equals 4 over 5. And
That's
then
perfect.
it would be the tan inverse, and I'll do that right now. Tan
That's
inverse 4 over 5.
it. Yeah, that's right. You've handled it in the correct way.
And that would be 38.66 rounded. And
Take
then,
angles up to one decimal place. So 38.7.
oh, okay, 38.7. And then, so since the tangent is positive, and the second solution is x equals 180 plus 38.7, right? So it'd be so that would be 180 plus 38.7, 218.7. And then all solutions could be just the same: 0, 180, 360, 38.7, and 218.7.
Those are correct. Question number 8, exactly same way. There's only one difference because we are just taking square root on both sides, and it would be plus minus, and we'll be working out for all four possibilities. Like this would summarize to sin x is equals to plus minus 1 by 2. This would summarize to 9 by 25 square root is 3 by 5. So tan x is equals to plus minus 3 by 5. So because of this positive negative, we will be finding angles in all four quadrants. Question number 9. Let's do one of these. This is quadratic equation. We'll go for midterm breaking. So question 9a says tan square x plus 2 tan x minus 3 is equals to 0. I can see we're multiplying 1 into 3. So tan square x plus 3 tan x minus tan x minus 3 is equals to 0. So we multiply these, I'm getting negative 3. Adding these, I'm getting 2. So tan x plus 3 minus 1 tan x plus 3 equals to 0. So the first one is tan x minus 1 equal to 0. That would be tan x is equals to 1. Second one is tan x plus 3 equals to 0. Tan x is equals to minus 3. We're getting two different basic angles. That's tan inverse of 1. I'm getting 45. So for the first one, x, it is positive. So tan is positive in first and third. That's 45 and 180 plus 45. That is 225. On the other side, basic angle is tan inverse of positive 3, and we get 71.6. And we knew it was negative, so tan is negative in second and fourth. So x is equals to 180 minus 71.6 is 108.4. 108.4 and 360 minus 71.6 is 288.4. Now we just write them in order. X is equals to 45, 108.4, 225, and 288.4. So it's 9A. 45, 108, 225, 288, 14. So just in similar way, these are quadratic equations. Try F part. Sin x plus 5 is equals to 6 into cos square x. I hope you remember few identities. One was tan x is equal to sine over cos. The other was cos square x plus sine square x is equal to 1.
So this is question 10, right? Just question 10?
F part. Question 9 F part. The one at top.
Oh, okay. I'm still kind of confused. I know we have to express
Yeah.
everything in terms of the sign identity.
Yes.
So we have to turn cos 2x into the equation. So it would be sine x plus 5 equals 6 into 1 minus sine squared x.
That's right.
And then, but afterwards expanding and then putting into the quadratic.
Yes.
That, yeah, okay.
I'm done.
Okay, I'm about to finish.
Okay.
Okay. I'll just compare my answers. 19.5, 160.5, 210, 330.
Exactly.
Okay.
So these types are covered. Trigonometric identities. Proving left hand side equal right hand side. First identity we're using is sine square x plus cos square x equal to 1. And few worked examples. 1, 2. Okay. Now these are so many trigonometric identities which are equal to sine x made subject out of the different one. And probably we're not using all of them. Only one or two would work. Okay, let's give it a try. Now, this is something which might need a lot of practice because we can't actually foresee what the shape would be. This is exercise 9.7, question 1. Sin x over tan x is equals to cos x. So we have to prove that left hand side is equal to right hand side. That's already sin x into 1 over tan x. And we knew that tan x was sine over cos. So if that's reciprocal, I can reciprocate it. That would be cos x over sin x. So left with cos x. So left hand side is equal to right hand side shown. Going for B part, that is cos x multiplied with sin x over tan x. We have to show that this is 1 minus sin square x. Now tan x is sin x over cos x. Cos x sin x divided by tan is sin x over cos x. Now this numerator divided by this denominator, if I just reciprocate it and convert it into multiplicative sign, this would be cos x over sin x. Sin x will be eliminated and I'm left with cos square x. And using the identity cos square plus sin square is equal to 1. Cos square is 1 minus sin square x. So left hand side is equals to right hand side. Try C part. 1 minus sin square x over cos x is equals to cos x. That should take 2 steps to show.
So we would first simplify the numerator. So it'd be 1 minus 1 minus sine squared x equals cos squared x. So cos squared x over cos x. And we would be just able to simplify the fraction. So we would get cos x equals cos x.
That's right. Right, D part.
So we know the identities already. So it's cos squared x equals 1 minus sine squared x, and then sine squared x equals 1 minus cos squared x. So we can start with like the left-hand side. So that would be cos squared x minus sine squared x, and it would be 1 minus sine squared x minus sine squared x. So that would just be 1 minus 2 sine squared x. And then with the right-hand side, that would be the so is cos x plus sine x, but 1 minus 2 sine x, sine squared x cannot simplify, so I'm kind of,
Stuck.
yeah, confused.
Now see, mathematically that was correct, but we cannot like foresee with less practice that what shape will it take. See, this was cos square x minus sine square x over cos x plus sin x plus sin x is equals to cos x. Now, one thing I'm under this impression that I'll be doing something that I'll disappear all the sign from left hand side to get cos. So first step, what I'm doing is numerator is cos square x minus sin square x and denominator is what? Without squares. So I am thinking about using a square minus b square, which is equal to a plus b into a minus b. Simple identity. So in the numerator, this I'm writing cos x plus sin x, that's a plus b into a minus b. Denominator copy paste.
Sorry, it disconnected.
Applied quadratic identity in the numerator. A square minus b square is a plus b into a minus b. So I could now just cancel out these two and I'm left with cos x minus sin x plus sin x is equals to cos x. So I'm just copying right side. That was not too much to write. So cos x is equals to cos x. Left hand side is equals to right hand side. Trigonometric identities would require a lot of practice, lot of written practice. Now see, if you just look at part F closely, that sometimes seems a little funny. The tan square x minus sine square x is actually equal to product of these. The difference of these is equal to product of these. Try F part. Tan square x minus sine square x is equal to tan square x into sine square x.
Could I quickly grab my charger?
Sure.
So which question was it?
F part.
F part. Okay.
And there's one more thing. If sometimes you feel stuck on working on left hand side, you can just stop there and start working on right hand side. So it would work vice versa. Left side to right side or right to left proved. Even let's say on left hand side you're on the third step and on right hand side you are on the fifth step. Even if these two are equal, you can still write them as left is equal to right.
Even if it's two steps away.
Yeah.
Okay. For this one, tan squared x equals sine squared x over cos squared x, right? So then we would plug that into the equation, and then negative sine squared x. So, oh no, you would have to plug it into both sides of the equation. So I'll just answer it. I'll just finish my working and
Yeah, yeah, sure.
Yeah.
Just do it and see if you're getting both sides equal. We're not just taking anything from left side to right side. We either work our way down on either side.
Okay, yeah. I'm getting sine 4x over cos squared x on both sides.
Like, okay. So you started working on left and then right, and you got one of the steps which is equal. That's okay. So similarly, question 2, then 3, and further trigonometric equations. We already used 2, which was sine square x plus cos square x is equals to 1. And the second was tan x is equals to sin x over cos x. Now there are more. Those are inverse of these. So 1 over sine x is cos secant x. 1 over cos x is secant x. I just memorized it this way. This is starting with S and this is starting with C. This is C and that's opposite S. And 1 over tan x is cot x. And these two. 1 plus tan square theta is equals to secant square theta. 1 plus cot square theta is equals to cosecant square theta. So we added 5 more. 2 cosecant square x plus cot started working, changed cosecant with cot. Once this all is in form of cot, that's quadratic equation would be just factorized, and then at the end, cot is being replaced with tan, taken reciprocal on both sides, and there we go. Same basic angle and the angle stuff. This is the third and last exercise of the chapter. I think we should directly come to question number 4. Have a quick look at 1, 2, 3. If it's okay, we can skip them and come to question 4 directly.
Okay.
Until unless we just apply those identities, everything else would be same. Exercise 9.8, question 4. A part says secant x minus 30 is equals to 3. So secant was 1 over cos. 1 over cos x minus 30 is equals to 3. I'm taking reciprocal on both sides. So cos x minus 30 is equals to 1 by 3. And this was from 0 to 360. 0x and 360 were they included? Yes. Now this is x minus 30. So this should be negative 30, x minus 30, and 330. So we're solving for y. Basic angle is equals to cos inverse of 1 by 3. Shift cos 1 by 3 is 70.5. So y is equals to, this is positive and cos is positive and first and last. 70.5, 360 minus 70.5 is within domain 289.5. And for x, we're going to take 30 on other side and add them. Plus 30 is 319.5. And 70.5 plus 30 is 100.5. This was 4A 9.8. Question number 4A. 100.5 and 319.5. Okay. Try 4B. The one at top. Domain is 0 to 180. For x.
Okay. 61.7 and 151.7.
4B. That's a little different. 73.3 and 151.7. Can you figure out a little, want me to solve?
I can try. I got 151.7, so I just messed up the first one, I guess.
Okay. That is minus 45 by 2. Whatever we're getting before that.
No, I can't. I don't understand why.
You're getting the second one correct. 151.7. What was
Yeah.
your basic angle?
Let me see. It was a negative 11.54.
11.54. Okay, I'll solve this for the first one quickly. 4B. Cosecant is 2x plus 45 is equals to minus 5. Taking reciprocal cosecant is 1 over sine. So sine of 2x plus 45 is equal to minus 1 by 5. Basic angle is sine inverse of 1 by 5. 11.5. But we know this is negative. So negative would be here, 11.5. So this makes 2x plus 45 is equals to 180 plus 11.5, right?
Yes.
So we're getting 191.5 minus 45 is 146.5 divided by 2 is 73.25. You were getting this answer, 73.3, done. Maybe some typo in calculator.
Maybe. Possibly. Because I was doing the same thing. I was doing 180 plus the 11.5. Okay.
Yeah. Hmm. Okay. So this needs to be practiced, like 9.6, 9.7, 9.8. And you have to get comfortable with these. 9.9 says further trigonometric identities. Odd one out, class discussion. Find the trigonometric expression that does not match each other. 6 expressions. So like we would just try and practice and tell which expression is equal to which one. Create as many expressions of your own. That's actually, I would say, a little unnecessary. For class practice, that's fine. But one cannot memorize all of these. So we would just work our way on spot. But practice is definitely needed. Worked example 1 plus secant x over tan x plus sin x on right hand side, that's only cosecant. Working on left hand side, numerator converted into simple sine cos, denominator converted into simple sine cos. LCM in both the cases is cos x, cos is cancelled out, we left with numerators. Sin x into cos x, sine taken out is common, cos x plus 1, cos x plus 1. Cancel out 1 over sine. Prove each of these identities. So that's just a further practice. Exercise 9.9. 5, 6, 7. Oh, yeah. Because these are identities, won't be in the answer space. 5, 6, and 7 are questions for values. Pick one out of this. Anyone. Which feels a little weird.
C part?
C part, okay. Let's try this. Both of us. You also do that, I'll do that. Parallel to save little time. Exercise 9.91C.
So cos C cos minus sine x equals cos x and cot x, right?
Yep.
Okay.
Okay. Let's try one out of question 2. Which one?
D part.
B, Paul. Okay.
D.
D, doctor. Okay, D.
I got cosec, cosec 2 squared x minus
You've already
sec
done it?
2x.
You already got the answer.
Yeah,
I still can't
because
get
it's
through.
just the identity. And then from then on, it's just simplification.
That's nice. And I think I still don't know if I'm going in the right direction.
Well, for me,
Oh,
I
what if
just
I just say,
substituted them.
yeah, yeah, yeah. Like 1 minus secant square and 1 plus cot
Yeah.
square. Perfect. Very nice. Secant square x and minus 1 minus secant square x. So, oh, yes, done. Seventh step. Nice. I couldn't think of that. Similarly, question 3 is just increasing little difficulty level. Again, question 4. And let's just try 5 and 6. These are not only identities, these would require answers. Question 5 says show that 3 plus 2 sine x whole squared plus 3 minus 2 sine x whole squared plus 8 cos square x has a constant for all values. So we just simplify and we'll get constant. All the identities should disappear. A square plus b square plus 2ab, then a square plus b square minus 2ab plus 8 cos square x. So first of all, negative 12 and positive 12 goes away. And I'm left with 9 plus 9 is 18, whereas 4 plus 4 is 8 sine square x plus 8 cos square x. So 18 plus 8 taken out as common is sine square x plus cos square x. That's 18 plus 8, 26. So shown that it is a constant at all times. Try question number 6. 5 sine square x minus 2 cos square x in the form. So that's all sine. That's double print, but I guess it's same minus 2 plus 7 sine square x. Are we
Double
getting
point?
this? Yeah, the print in the marking scheme.
Oh, I'm on the last step, but I think I'm getting the same answer.
Okay, thank you. B part. State the range of the function. Now, do you remember these sketches? This is the exact same question. So it could be written as we've already done. So what would be the range? range of the function.
So then it's negative 2 greater than or equal to f of x greater than or equal to 5.
5, yes, and -9, I guess.
Negative 9.
And -9 less than equal to 7 sine square x minus 2 less than equal to 5.
I'd
See, if you
put,
just look at this part,
yep.
this shows you that 7 and minus 7. 7 and minus 7 because the amplitude is 7. Then -2 would bring this down 2 units. Everything down by 2 units. So 7 drops down to 5 and -7 would drop down to -9. So
Okay.
range of the function f of x is from -9 to 5.
Okay.
So this is done. That was chapter 9, trigonometric identities and trigonometry, graphs, quadratics, simple equations. And then in the next class, we'll start with